So remember where we are coming from. We have seen the sparset implementation. It was used by the domains. Then we have the variables that are also using the domains. And then we have the constraints. Okay, and as you have seen, the two are really interleaving. So variables are also storing the constraints. Okay, and the storing constraints are also acting on the variables as well when they are pruning the domains of the variables. So a constraint is an API that has two methods, two main methods, the post method and the propagate method. The post method is really a kind of constructor, if you want, that will be in charge of stating the constraints and hooking up the variables to say, I'm interested to be notified when something changes in your domain. And the propagate method is really the one that will kill the values, kill all the inconsistent values according to the semantic of the constraints. So if you remember, we have seen the difference, x different from y case, and when x becomes bound to a single value, you might need to remove this value from the domain of the other variable. And we will see an example of this. So the constraint is an interface. It has first the core API is this one, but you will see that there are other methods that I will call the performance API. These methods are there just for performance reason. For instance, you don't want a variable to be scheduled twice inside the propagation queue during the fixed point algorithm, and this is why we need this kind of method. Or you might need that this constraint will be satisfied whatever happens inside the domain. So you don't want this constraint to be notified again. You just say, remove my notification. I don't want to be executed again. And this is what you can do with set active or set inactive methods. Okay, but this is a little bit less important. This is more for performance reasons that we use these methods. So it's an interface. So we will propose an abstract constraint implementation, which is a partial implementation. Everything is implemented there except the post and the propagate. But by default, all the performance API is implemented for you. You don't need to worry about that. All you need to implement is post and propagate. But the state manager and the performance API is already implemented. So if you want to implement a new constraint, just extend this abstract constraint, okay, so that you only have to worry about the post and the propagate method. Okay, so x different from y plus c. In the post method, you just need to hook up the constraint. So we want to hook up this constraint that we are currently implementing to the changes, the bind changes on x and y. And when this happens, it means that propagate will be notified. And so you are sure that when propagate is executed, you know that either x is bound to a single value or y is bound to a single value. If this is the case that y is bound, you can safely remove from the domain of x the value that it has plus c. Okay, and we know that there is a single value since y is bound. Okay, so minimum is equal to the maximum is the single value. Otherwise, when x is bound, you can remove from y x minus c. And since once one of the two is removed, you can deactivate this constraint to say that you don't want it to be notified again. This is more for performance reason that you do that, okay? Because you know that since one of the two constraints has been one of the two variables has been bound, and you have removed this specific value inside the other variable, whatever happens in the subsequent changes, it won't violate the constraint anymore. Okay, and this is why we deactivate the constraint. What I propose next is that we implement a constraint inside minicp, and this is one of the constraints that you will use inside for solving the Enigma puzzle.